Так, всем привет. Это Дмитрий Фридлин сейчас говорит. Виталий Рудницкий из Вроцлава у нас на связи. Виталий, ты здесь?
Да, надеюсь, меня слышно.
Да, прекрасно. Я вижу, у нас уже больше 50 человек присоединилось. Я думаю, дойдут еще. Пока что для тех, кто присоединился. Виталий, а можешь включить себя, показать? Я тебя видел, но не все. Вот, это презентация на экране, я вижу.
Секундочку.
О, прекрасно. Я просто пару слов скажу, прежде чем Виталик начнет рассказывать про SAP HANA Advanced Analytics. Когда 10 лет назад я начинал заниматься ханой, вот это был 2010 год, она еще релизнутая не была, но я в SAP уже ей занимался. Был миллион вопросов, она особо никогда толком, в те годы, да, дорелизные. Было миллион вопросов, и никто не мог ответить. И каждый раз, когда я гуглил что-то про SAP HANA, я всегда натыкался на блоге какого-то Сигизмундовича. Я этого Сигизмундовича не знал, но имя запомнил. Ну, такое странное имя, да. Потом я в какой-то момент определил, что Сигизмундович – это Виталий Рудницкий, но из Вроцлава, и в полной уверенности. На тот момент, по-моему, ты работал в HP или, где-то работал, не в SAP, да. И я все равно никогда не думал, что Виталий вот говорит по-русски и так далее, потому что имя достаточно такое, мы все тут близки. И вот с тех пор я просто виртуально знаком с человеком, никогда мы не разговаривали, но я всегда знал, что есть такой мега-специалист в Хане, который еще 10 лет назад, когда не было даже продукта, писал о нем блоги. А потом, через какое-то время, мы познакомились вживую. Я узнал человека на самом деле. Я узнал, что он перешел в SAP, что он работает адвокатом разработчиков, если по-русски, в таком достаточно новом юните, который, кстати, возглавляет Томас Юнг, верно?
Да.
Сейчас, да. И очень классно, что ты нашел время, и, к сожалению, не смог прилететь, потому что наш очный ивент, на который вот был запланирован, пришлось из-за пандемии отменить и перенести в офлайн. Но большое спасибо, что ты нашел время, и вот сейчас нам расскажешь по SAP HANA Advanced Analytics в рамках SAP Tech Talks.
С удовольствием.
У меня все.
Да. Спасибо, Дима. Но, к сожалению, мы предупреждали, что этот вебинар будет по-английски, поскольку мой, скажем так, главный язык общения – это польский, а главный язык общения на работе – это английский. Поэтому нам придется переключиться все-таки на английский, когда мы начнем презентацию.
И это тоже прекрасно, что позволило нашим англоязычным слушателям, хоть они и не поняли вступление, но вот выслушать твой доклад. Это прекрасно. Все, начинаем.
Ладно, я в таком случае выключаю камеру. Показался, но постараемся сосредоточиться на Хане, не на мне. Окей. Только еще хотел убедиться, надеюсь, слайды видно.
Да, мы видим.
Супер. Okay. So from now on, as I mentioned, sorry about that, we are going to switch to English, and I hope that is not going to be a problem for anyone. Let me just quickly reintroduce myself. I was born in Ukraine, but I spent fewer years living in Ukraine comparing even to my work career. I spent most of my life in Poland, but indeed, when I needed to pick the nickname for my Twitter handle, I didn't think long, and maybe it was a mistake, and I picked Sigismundovich because my father's name is Sigismund. So obviously for you, it should be obvious what Sigismundovich means, but for lots and lots of people out there in Europe and in the US, it is something really terrible to understand and to pronounce. As Dima mentioned, indeed, I spent about 15 years being a technology consultant working for HP before I joined SAP 8 years ago, and at SAP I am working in the office of CTO in the global developer relations team with main focus on all things data. And I am based in Wrocław. So if you've never heard about it before, I put more or less where it is on the map, but we are going to go back to maps a little bit more today, so no worries. Before joining SAP as well, I was one of SAP mentors. So SAP mentors are people from SAP community who are passionate about particular technology and about providing feedback to SAP. So my thing was always, as I mentioned, in data and in analytics, and I was the SCN topic leader for something that was called BIBW Accelerator at that time. And similarly to Dima, who is organizer of these community meetups in Minsk, I am organizer of such an SAP community meetups here in Wrocław, including something that is called SAP Inside Track. And SAP Inside Track is the full day, usually on weekend, get together for the community to share the knowledge, to share expertise. And even though because of this whole pandemic situation this year, we couldn't organize it in May, as always, we are still planning for the last weekend of September to have it here on site at one of the universities in Wrocław. So obviously, if borders will be open by that time, and if it will be possible to travel without major obstacles, you are more than welcome. And actually, it was SAP Inside Track in Waldorf, where Dima and I met face-to-face January this year as well. Okay, enough about me. Unfortunately, I need to show this slide because, as I mentioned, I do work for SAP and this is obligatory, but now let us move right to the topic. So how do we get here and why are we talking about HANA Advanced Analytics? SAP was established in 1972 when 5 IBM engineers decided that mainframes that they are working with is something that can be suitable as well to automate business processes. But at that time, relational databases as we know them today even didn't exist. So not Thomas Young, but we have another colleague in our team, DJ Adams from Manchester, from the UK. And he's the guy, the one and only in our team who still remember running R2 on file systems before it was migrated on relational database. But the end of 1970s is the beginning of this relational database, SQL as the query language, the only 4th generation programming language that still survived till these days. We are entering 1980s, and with the popularity of desktop-based relational database management systems, this whole database and SQL are becoming even more popular, specifically thanks to MS Access that many of us might have had still during our student years. 1990s is really the year of rapid increase of SAP implementations. It's all primarily thanks to the change in computer architecture from mainframes to client server. And this is where SAP was one of the pioneers and riding this wave to finally arrive to year 2000. I will skip this whole Y2K problem, but this is the other milestone that caused many enterprises to think about changing and refreshing their business support systems. So yet another milestone for SAP and SAP customers and partners. But let us have a look into years, into zeros years. And I started working with SAP technologies in 2003. At 2008, when this particular report by Gartner was published, I did work for HP in Silicon Valley, so I was based in the US. And I still remember that at that time, we could literally count all the customers of SAP who would have more than 1 terabyte data footprint in their ERP systems, like just with fingers on one hand. But now, having 1 terabyte data sounds like it was really tera years ago, because what happens during these zeros is, on one hand, the rapid increase of web technologies, and these web technologies required storage and processing of much, much bigger amounts of data. On the other hand, popularity of mobile technology and ubiquitous of smartphones caused the customization, the increase in requirements to have much faster response time. And this is why I'm saying that if SAP wouldn't invite or wouldn't come up with HANA in 2010, would need to come with something similar, because with this ever-increasing footprints of data in ERP systems, CRM systems, BW systems, and so on and so forth, we at SAP, now I can talk about SAP as a part of this, we really needed this kind of technology. But SAP HANA is still the relational database, SQL based, while the requirements that were generated by web and mobile, and later on as well by IoT, caused as well increase in popularity of so-called NoSQL databases. And with this, we are arriving to 2020, and the question is kind of like where all this technology is going from now. And I don't want to talk about pandemics, because obviously 2020 we will always remember as this COVID-19 year. But if we are going back to technology, there is this survey that Forrester ran on our behalf among our customers, asking, so what is the kind of data you need to work with in your environment? And even though this structured relational data still remains at the top of all the customer needs, you can see, and obviously you know this as well from your own experience, there is more and more of documents, text, graph, images, spatial data, and semi-structured data models that have to be processed, stored, ingested, and so on and so forth. They are causing some issues, such as once we have all these different data stored in different places, then we need to integrate this data. Sometimes we need to move this data from one place to another, changing the structure, and this is causing data duplication. And as many places being used to store this data, it is obviously causing as well some increase in data security and compliance issues. So out there on the market, there is this new, maybe not that much new, but the new wave of systems coming, which are referenced as multimodal databases. And these multimodal databases are this database engine that can store all these different kind of data in a native form right in the core of the database. And here, the reason why I put this slide is that I just would like you to pay your attention to something that is called OrientDB, and this OrientDB is an SAP company. So I used to say that we acquired this database by accident. Basically, we wanted to have some additional capabilities in the area of managing sales data. We acquired the company that was called Calidius Cloud, and with Calidius Cloud, we got as well OrientDB, the small startup that was acquired by Calidius Cloud even a bit earlier. OrientDB is a small footprint database that, as I mentioned, is multimodal in nature. It still has its customers and so on. The reason why I'm saying this is that I just wanted to prevent hopefully any question just like, oh my God, what is going on? You have HANA, you have OrientDB. These are two completely different set of customers using this. And with that, let us move to SAP HANA. So SAP HANA was called or was placed by Forrester as one of the leading so-called translytical data platforms. And if you never heard about this before, translytical means the database that can combine in one place both transactional kind of processing, which is ERP transactions, CRM transactions, SCM transactions, and so on and so forth, but as well analytical workload, such as coming from data warehouses, operational reporting and analytics, or, for example, multidimensional queries. Part of the functionality of SAP HANA as this translytical database platform is being able to support advanced analytical processing, which, as you can see, somewhat reminds the qualities that we mentioned before for these multimodal databases, like support for spatial or graph or semi-structured data, native support for text search, and so on and so forth. But the difference is that at this very core, this database like SAP HANA still remains relational database, and all this advanced analytical processing is coming as an extension on top of that. I'm going to use the free version of SAP HANA that is called Express Edition. If you are interested in SAP HANA, that hopefully you have seen this already. If not, then just a reminder that SAP HANA Express Edition is the smaller footprint of regular SAP HANA commercial option that allows you to have even productive use up to 32 gigabytes of RAM for free. But because we are talking about this as a free option, so there is no SAP support other than just community support coming with that. And this SAP HANA has pretty much the full scope of all the regular HANA functionalities, including this advanced analytical processing, and it is coming in several different ways to deploy or install it. And the version that I'm going to use is the cloud image that is running on Google Cloud Platform. And this is where I would like to switch to demo part, and I hope that everything will still work, right? So right now I am on Google Cloud Platform, and I have here one virtual machine that was created from the template that is available on this Google Cloud Platform already. If you have this interest in technical things and you never tried working with one of these cloud platforms before, I would certainly recommend you to give Google Cloud Platform a try, because they give you $300 credit for 12 months. And for me, for example, it was enough to run this HANA Express for free for 8 months and to play with this, right? So just quickly, if we would go to the marketplace here and we would type HANA Express, then you should see that there are 2 predefined images already available, and the one that I'm going to use today for all our demos is this one, SAP HANA Server Plus application layer. And again, as I mentioned, you can just simply launch and deploy this even in this free account. As I mentioned, I have already this pre-deployed, and this is the version that we are going to use. It comes with application layer, and therefore the regular IDE that you can use that is called Web IDE is already available here, and we can use. But I would like to start with the geospatial qualities of HANA, and therefore I'm not going to use Web IDE for that, but I'm going to switch to this open source IDE that is called dbeaver. And this is a community edition, so it is free as well to download and to use. And what is nice about dbeaver on one hand is that it does support connectivity to HANA. So I have this connection to my HANA Express already defined here. And the second nice thing about this is this database IDE, or integrated development environment, has really, really nice support for geospatial data that should come handy for us. I used to run the full day CodeGem workshops, SAP CodeGem workshops on geospatial in the past. And one of the very first exercises that we usually would do there would be to find the once and for all answer to what is the central point of European continent. Because in the past, if you would be interested and you would check the history, then there are multiple countries that are claiming to be the central piece of Europe. So this is where, as I mentioned, I usually start. So in this case, I have already world continents data loaded that are coming from ArcGIS. This is the open data set that everyone can download as well. And as you can see, it has continent name and it has the shape. And this shape has a data type of st_geometry. ST stands for spatial type. And this is a kind of spatial type that HANA supports as well. So if we would like to see what is in there, then we have several continents here, but the one that we are interested in is where continent equal Europe, right? So this is the one that we selected. And as you can see, something that I mentioned, this dbeaver already supports the spatial preview. So if we go to the spatial preview, then you can see the shape of European continent. And what is really nice is that we can place this as well on the map preview, right? So I hope that you see it really well. And so far, I only showed that we can load and display, load and store this geospatial data in SAP HANA, but let's, as I mentioned, try to use one of its geospatial functions to find where the center of Europe is. So there is the whole bunch of spatial type methods that we can use, and one of these is so-called centroid. So centroid is nothing else but just a central point of any two-dimensional shape. But before we can run it, if I run it, actually, we should see the error, because right now the data that we loaded is round Earth. And round Earth means it is three-dimensional, while centroid is a two-dimensional function. So before we can run it, we basically need to just change this to two-dimensional flat surface. I hope that there are no too many flat Earth believers among us, but now we calculated this central point, and let us try to visualize this, right? So we need to place it again on the map, and let us just zoom out to check where the central point of Europe is. Congratulations, it is in Belarus. And you should see faces of people in Western Europe every time I run this query and they find that the center of Europe is actually in Belarus. Really priceless to see their faces, because sometimes even Germans are thinking that they are in the middle of Europe. Okay, but let us try to do something more fun with this geospatial data. So I don't know if you are aware of, but basically Google, and I assume that many of you are using Google, tracks data about you, right? We are using Google products for free, but if you are using a product for free, then basically you are the product, right? And data about us is what makes Google make their money, obviously. But now with the popularity of different regulations, like for example, European Union GDPR, all these companies, including SAP, basically should give you a way to collect all the data that company knows about you. So with Google, there is a service that is called Google Takeout, and this Google Takeout allows you to basically check what kind of data is being collected, if you are using Chrome, if you are using Contacts, if you are using Google Drive, if you are using Google Photos, and so on and so forth. But the one that is interesting for us is something that is called location history. So if you are using Google Maps and basically you see yourself on the map, Google sees you on this map as well and stores your history if you do not change some of the settings, and if you do not restrict how much history, or if they can even collect this history about you in the first place. It would take a couple of minutes, therefore I already kind of like requested this data before our webinar. I downloaded this, I uploaded this to my HANA database virtual machine. So right now I am on the I am in the server that is running my HANA virtual machine, my HANA software. And basically, as you can see in the directory that is called Takeout Location History, I have this file, and this file is exactly and this file is exactly the history about all the locations that Google recorded about me for several years. But if you look at this data, you can see that it comes in the format where the timestamp is basically Unix timestamp, and where latitude and longitude is represented in some particular as some particular integer numbers, and all this data is in so-called semi-structured format. So basically, it is not structured like CSV, but it is JSON semi-structured data, and that they can have therefore flexibility to store data about in the same place, even if the structure of this data is changing, right? So we looked at the very top of this file, and you could see that at that time it was on the location and the timestamp that were persisted. Now closer to recent years, I'm looking at the very end of this file. In addition to that, there is information as well in what direction I was moving, with what speed. And actually, if we want to see even more, then there is this funny thing, 2020, no. Just give me a sec. Right, so based on this data that we are sharing with Google, they can even estimate that, for example, we were moving from one point to another, and during this movement, most probably we were in the passenger vehicle. Let me just increase a little bit the font. So with probability 65%, we were in this passenger vehicle in the car, or with probability 1%, I was really walking fast, and so on. But okay, let us now just move. So what can we do with this data? And because, as I mentioned, in HANA, we can store semi-structured data as well. So it means that we can load this data, and because it's sort of geospatial data, we can do something really funny with this data as well. So let me just, I prepared already a few, sorry. I prepared already a few SQL statements there, because as I mentioned, HANA is still the SQL database, right? So I imported this location history file already so that we do not waste time. And then I read this semi-structured data just by using JSON table SQL statement, and I needed to so-called parse this data to turn this into data that is now relational in relational format. And if we look in this Google schema, I created the table now that is called Google location history of me with just timestamp and the point is just GPS or geospatial point where I was at that time. And as you can see, the data that is being collected about me is from 2013. Obviously, you as a consumer can change this, but in my case, I don't care. I'm really curious to collect all these points. So let's just, have a look where I was during this month. So for the months of June, for the year of 2020, I can just collect all these points. And if we look at them on the map, you can see that indeed I have moved outside of my house, but I do stay in Wrocław. So there are no business trips for me since March. Okay. And as you can see, it is not that every single location at every single point of time is being collected, but still quite regularly where we can find where I used to be at particular time in this month. Now we look here at the points, but what is more often is once we are getting that many points, we want to look at them in clusters. So let me now do so-called spatial envelope clustering of all the points in all of the history, just to see where I used to be. So since 2013, these are all the locations that have been recorded. Frankly speaking, I haven't been to Africa. So it was clearly just a mistake by Google. Probably satellite was just had the clock not in sync, and for whatever reason, at some point of time, Google identified that I was in Africa. Now I wasn't here, but basically we now just did the clustering of all these points from the history. What is more popular recently, instead of using this envelope or square clusters, is the usage of so-called hexagons, because hexagons allows us to build something that has always shared site with another hexagon, right? So in this case, within the boundaries of Poland, and this is the boundaries that I described here for the latitude and longitude, I can restore areas where I was moving in Poland during this time that data was collected. It is really funny that as well Lviv in Ukraine is here, but this is just because, for the boundaries, I was using the square boundaries, and therefore it is going in some cases as well outside of Polish border lines as well, like all the way to Berlin or to Prague. Okay, what else funny can we do is we can as well restore the route that was taken on one particular day. So I was looking if there is anything interesting in this history. So 1 week ago, we took a bike trip with my family. So now I can use, again, special type methods from HANA just to build the line string, or basically build the chronological string of points. And what have I done here wrongly? I just incorrectly ran this query. So again, placing this on the map, I can restore the route we took on bicycles, trying to go through parks, actually to some lunch place just to have some Oriental food, and then looking for the ice creams, and then biking all the way back home. Okay, so that was about processing spatial data and processing semi-structured or JSON data. Now for another demo, I would like to switch to Web IDE, because now I want to focus on processing graph data. So graph data or connected data is something that obviously every one of us who is using social media, for example, is aware of. And in my case, I found the free data set that contains Marvel superheroes. So I hope that you are familiar who Marvel superheroes are. These are all the Iron Mans, Hulks, Spider-Mans of the world. And basically here we have two tables. One is the nodes of all the heroes. And I was really surprised to learn that there are so many superheroes in Marvel. And if you were not aware of that, then let me show you that there are even two Belarusian superheroes in Marvel universe, Lainia Petrovna and Nikolai Krylenko, and they were both born in Minsk, as we can find in their so place of birth, Minsk, Belarus. So I will leave this for your own exploration if you would like to look into this data. But basically we have these two tables. One is describing all these heroes and villains from Marvel. Oops, sorry, that's the wrong one. And even in this case, we have 6,000 superheroes. And from what I know, there are about 15,000 if we count all of them. So we have 6,000 superheroes in this particular data set. And then we have another table, which is called network. And basically this network describes who of these superheroes met, be this in comics, be this in the movie, some of the other superheroes, right? So for example, Captain America met in the past Thomas Ryan or Jim Wilson, and I have no idea who all these people are, because even though I watched some of these Marvel movies, I haven't read all of their comics, and neither did my son. But as you can see, we got something that we can call connected data, right? So we have nodes, which is particular people, persons, superheroes, and then we have all these connections between them. And once we have this kind of connected data, we can build in HANA something that is called graph workspace. So in this case, I called it social network of these Marvel superheroes. right? So we have vertex table on nodes, and this is our table with the superheroes, and then we have the edge table, so basically table that defines connections between them. And with such a defined graph, now we can even use HANA to see this graph, right? So we have 200 random points loaded, and now we can see from here that there is a superhero that is called Analyzer, and he is connected with 148 other superheroes. It is directed graph, so basically we should expect that that every graph that connects, for example, the superhero who is called Agba to the superhero called Analyzer is going in both directions. But now having graph like this, we can run as well some graph native algorithms on this, like finding, the shortest path between two superheroes, or finding the neighborhood in one or two circles around them. But I wouldn't like to focus too much right now on these superheroes, but I wanted to show you some other example. And this other example is coming from the challenge that I had for the participants of one of my workshops during SAP TechEd, where after we went through all these graph capabilities, I gave them homework if they can use graph capabilities to solve so-called chess knight problem. So the knight problem is basically knight is koniok, if I remember well, in Schachmaty, and this is where you need to travel the whole chessboard with this knight, visiting every field on the ones, and you need to visit all these fields. So basically, if we look at this from the table structure, then obviously our nodes here are nothing else but just all our 64 fields on the chessboard, going from A to H and from 1 to 8. And all our edges is nothing else but just the movements that knight chess piece can do from each particular field, right? So from A1, it can move only to C2 and to B3. And then from C1, it can move into 4 different places. So as you can imagine, now we do have the table that we can represent, or 2 tables that now we can combine, and we can represent them as a graph. Obviously, HANA doesn't know that this is chessboard, so maybe the location of this, of all these nodes is somewhat random, but basically you should get the idea that, for example, from E5 you can jump on to G6. And now, if we have this data in HANA, can we solve the problem of this knight tour? For that, there is no out-of-the-box algorithm, and therefore, in this particular case, we need to run our own procedure. So the solution that was proposed came from one of participants of my workshop, Șerban Petrescu, who is Romanian, and he wrote this procedure where basically it says use the HANA graph language, but read SQL data, and this is his algorithm to resolve this. So if we try to execute this, and let's say we start from the field A2 and let HANA execute this, so we got 64 results, or 64 answers. Obviously, in this case, there is no, because we are in HANA tooling, there is no special UI to visualize how this chess piece was jumping on this chessboard, but you can basically trace that from A2, it would move to C1, and then to B3, and then to A1, And that way, there are 64 movements. So basically, we jumped around all of the chessboard and visited each place only once. Okay, so that much about using the graph advanced analytics. Now let us move to one more capability, which is predictive analytics, which is a part of the portfolio of advanced analytics as well. And this is where we will move back to our Marvel data set, where, as you remember, we have this connected nodes or connected superheroes. And even though usually when we think about this predictive algorithms, we are thinking just like, okay, predict the sale for next quarter based on the history data, or predict I don't know, our spending based on historical data. The range of these predictive algorithms is going much further than just simple linear regression like this. And one of the really interesting algorithms that I wanted to show you is, for example, something that is called link prediction. So when we have connected data like the one we were seeing, for example, with Marvel superheroes, now we can predict what would be the next most probable connection that doesn't exist yet. So you can imagine that, for example, if you have LinkedIn, then LinkedIn would suggest you some connections who you should connect to. If you have Twitter, Twitter would suggest you some people to follow. And these are examples of nothing else, but just specifically exactly this link prediction algorithm that we can run in HANA as well. So if I just go back to here, and let me just see quickly if I have prepared here. No. Okay, we can go to the Beaver for this specific one as well, because I should have opened it. Marvel link, right? So here we are going to use again our tables that store this Marvel data. We have this network, even though in this case we have a view of on this network, and we are saying that use specific predictive method. And what it means is basically even to calculate this next connection, there are 4 different algorithms available, right? So each of them has different mathematical models behind. For whatever reason, I don't remember why, I picked method 2, which means this is some Jacquard's coefficient method. And if anyone is interested, obviously can just do the web search to read more about this algorithm. But now if we go back, we can just call predictive algorithm library from HANA, and we can call this link predict algorithm, because there are, as I mentioned, 7,000 nodes, so it would take quite a few, something like 3 or 4 minutes to calculate. So therefore I did execute this already, and I stored the results of this prediction algorithm already in the table that is called LP results. If we would like to see what is stored in this LP results, then basically there are 3 columns, which is saying, so this is node 1 or 1 superhero, this is node 2 or second superhero, and what is the probability of them making the connection. Score 0 obviously means that probability is pretty much 0. Therefore, if we just want to look at this data somewhat differently, where we would see some meaningful result, then let's just order this by score. So you can see that, for example, it is very high probability that in one of the next movies or comics, Luke Cage will meet Marvel Girl, which is Jane someone. Again, I'm not that much familiar with them, but I basically believe that it does make sense. And this way, for example, we could calculate for Thanos who he would meet next. But from what I've seen in one of these last movies, Thanos is dead. Unfortunately, it is not reflected in our metadata nowhere, but basically it is highly probable that if Thanos would live, he would meet Jonah Jameson or Ant-Man 2. Okay, so it was just an example of again using built-in predictive capabilities from SAP HANA. So if any one of you would like to try this out by yourself, SAP HANA Express Edition, as I mentioned, is the free version, but something that requires you to either have quite a powerful laptop or use, for example, one of these cloud vendors like Google Cloud Platform or Microsoft Azure. If you just want to try a little bit of this, there is still a chance to do it by going to the free tutorial that we prepared that is called Help Thomas Get Started with SAP HANA. And in this case, basically, you are using free SAP Cloud Platform trial account. So this is HANA trial on demand. And if you never used it, you can try it out as well, right? So it is 30 days free trial account. And within this trial account, you can create your own HANA schema completely for free for the 30 days. And you can just use it to play with this exercise that I showed before, where we are loading again some semi-structured data. And then in this semi-structured data, we are running some of the graph algorithms and some of geospatial data, just basically to help our fiction hero to find someone who is based close to him, and he is based in Munich. So the real person behind this whole exercise is our vice president of our organization at SAP, Thomas Grassel, who is a real person living in Munich. Okay, so going back here, and all the demos that I showed as well, they are available on the SCN, SAP Cloud Network blogs. Most of them are coming from my blogs there, but as well I used some of the other blogs, for example, from Sherban, with his Knight's Tour problem on SAP HANA Graph. If you're not much familiar with OpenSAP, then OpenSAP.com is our free platform for massive online courses. And we used to have 3 courses specifically to cover this advanced analytics in HANA. One was about full text search, another one about spatial analysis, and the third one about analyzing connected data. So if any one of you really interested to dig into any of these topics, archives of all these courses are available there. And as well, recently, because we were not able to travel, and my work is primarily about traveling to different community events like SAP Tech Talks in Minsk, something that we did plan I would attend in person. We had to switch to more online webinars and live streaming broadcasts recently. So I included this link here if you want to see me, if you're not annoyed yet listening to my voice. Recently I was I did some of this live streaming coding, digging into SAP HANA, using SAP Cloud Platform Trial, using SAP Data Intelligence. trial to ingest some of the data into HANA, and as well during SAP Online Track, which was the 24 hours around the globe SAP community event with many people presenting. I did the presentation on the topic of data visualization and showing EDA, or exploratory data analysis, with SAP HANA, and some canned reporting based on IBCS standard with SAP Analytics Cloud. So if any one of you is interested in these topics, you are more than welcome to catch up with these recordings on my YouTube channel. And with this, I would like to thank you for your attention. And now we can switch to questions if there are any. So far, I don't see any questions in this questions panel. Okay, not that much of a question, but thank you.
There is one saying thank you. And thank you, Vitalij.
Thank you as well.
The big one.
Not that much of
thank you
questions there. And I know that maybe I took a little bit more time, so we are at the top of the hour as well, where people might switch to their other activities. So thank you everyone for joining. Thank you, Dima and the team, for organizing this. Thank you, Sasha.
Thank you, Vitalij, for coming. Thanks for finding this time. And I really hope that one day you will come here offline.
The hope is mine.
To the real event. Yeah.
Okay, so there is just one question as well at the very end. Is HANA Express Edition free for commercial use? Yes, this is what I mentioned as well. Up to 32 gigabytes. It can be used for productive use cases as well. We have a few customers using this, but as I mentioned, because it is for free, there is no commercial support that comes with that. So if there is any issue or any question, you would need to go to Q&A forums on SAP Community Network and look for some expertise from fellow users there. Okay. Дякую. Спасибо. Have a great weekend.
Thank you.
Bye-bye.
Bye.
Take care.